Welcome everybody to Functions Lesson 4 and Fun Number 5. We're going to try to put these together into one video, and hopefully it makes everything a little bit nicer. One video seems shorter than two videos, even if one video is longer. So we have been looking at using function notation, and now we are going to use function notation and solve some problems. So in the last assignment, there was a question number 6. I'm not sure if I assigned it or not, but it had to do with candle, the time it takes for a candle to burn. So we're actually looking at relating the height of the candle versus the time. So it says here, the candle manufacturer found that their long-last candles melted according to the formula h of t is equal to negative 2t plus 12, where h is the height of the candle in centimeters and t is the hours. Using a graphing calculator to sketch use a graphing calculator to sketch the graph of a function and show the graph on a grid. Okay, so the first thing I actually want to talk about before we do that is the independent and dependent variable. So we have two variables. We have h for height, and we have t for time in hours. So which one is the dependent one and which one is the independent one? Think about it for a second, and if you thought that time was your independent variable, you are correct. So we are going to put time on the x-axis, and we ended up putting height, or h of t, on the y-axis. Time is normally independent. I think 99% of the time is independent, and the height of the candle depends on how long it's burning, right? Okay, so there are going to be times where we need to use a graphing calculator, and there's a really cool app you can get on your phone called Desmos. It's Desmos. So it's the Desmos graphing calculator, and you can use it to graph some of these functions. So negative 2t plus 12. So if I come up here to, this is the Desmos web browser, but the app looks very similar. So I need to plug in, the formula. So I had negative 2 and, hopefully that doesn't keep going up. X I'll use for, okay, we're working on it. We're going to work through it. So it's negative 2x, and then it was plus 12. So I'm using x instead of t. I mean, they're both variables. Plus 12. There we go. We have our graph here, and you can see that we have the y-intercept of 0, 12 and the x-intercept of 6. So what we can do is we can come back here and we can graph that. So we're just going to sketch a graph. It doesn't have to be exact. It did something like this, where this was 6, 0, and the y-intercept was 0, 12. Now it says determine the value of h of 5. So that means that h of, usually our calculator is h of t, so that means if we have h of 5, that t is equal to 5, right? So we can say h of 5 is equal to negative 2, and I'm going to put 5 where there's a t, 5, plus 12, which is negative 2 multiplied by 5 is negative 10, plus 12, negative 10 plus 12 is 2. So h of 5 is equal to 2. Write in words the meaning of h of 5. Well, we said t is 5, so the h of 5 is going to be the h of 5 is the height of the candle after how many hours? After 5 hours. So we know that the height of the candle after 5 hours is 2 centimeters because we calculated it. Evaluate the following and explain the significance of each. H of 0. So this means that h of 0 means that time is 0. So h of 0 is going to be -2 multiplied by 0 plus 12. I'm just putting a 0 in anywhere there's a t in the equation. And we know that, I don't know what I just did. I really wish I was more computer literate. Okay, -2 times 0 is going to be 0 plus 12. So h of 0 is equal to 12. And the significance of that is that at time 0, that's the starting height of the candle, right? That is how tall the candle is before we even start burning it. Oh man, what is happening here? H of 6 is the height of the candle after 6 hours. So again, you could calculate that. Say -2, put a 6 in for t, plus 12, and you can see that -2 multiplied by 6 is -12 plus 12. So h of 6 is going to equal 0. So that means that's how long it takes for the candle to burn all the way down, because now our height is 0. So it takes 6 hours for the candle to burn all the way down. We know that if 6 is the max amount of time, h of 8, it ends up giving us a negative number because, that line does technically keep going, but it doesn't really have any meaning in the context of this problem because you can't burn to a negative height, if that makes sense. The next one says, how long will it take for the candle to burn down to a height of 7 centimeters? What that is saying, I'm going to do it up here. It's saying, what is h of t, or what is t when h of t is 7? So we can take our equation, h of t is equal to -2t plus 12, and we can put a 7 in here. 7 is equal to -2t plus 12. And then we can do some algebra to solve for t. So I'm going to subtract 12 both sides, and then I'm left with -2t on this side. 7 minus 12 is -5. And then what I can do is divide both sides by -2. I need to get rid of that -2. And that cancels things out on that side. I should have used green, sorry. And I'm left with t on that side. And then -5 divided by -2 is positive 2.5. That means it's going to take 2.5 hours for the candle to burn down to a height of 7 centimeters. Hopefully that makes sense. Suggest an appropriate domain and range. We know domain is the x values. So basically, we don't want to have a negative time. So we want our x values to start at 0 and go up to 6. We don't need to go any further past 6 because that's our stopping point. We have no more values. So we can say x has to be greater than 0, or 0 is less than x or equal to, and equal to or greater than 6. And my range is all the y values. So if I look here, the highest value is going to be 12, and my line disappeared again. So I don't need to have any y values larger than 12 or less than 0. So 0 is my low limit, 12 is my upper limit. I put my y there, and I put my arrows in pointing to the left, and they're equal to as well. So I'll put that in. Hopefully that makes sense. That is the notes for lesson 4. We're going to roll right into lesson 5 here. So now what we're doing with lesson 5, or should I just start again? Hello everyone, and welcome to Functions Lesson 5, Interpreting Graphs of Functions. So now what we're going to do is we are actually going to pull information from graphs that we can see, rather than plotting the graphs from equations. So we need to be a little bit creative here and think about what's actually happening in this graph. So it says the Carter family are driving to the Yukon for a family vacation. The graph represents the amount of fuel in liters in the gas tank of their car on the first day of their journey. So you can see on the y-axis we have amount of fuel, and on the x-axis we have the time of day. So it's divided into line segments here. We have the AB segment, the BC segment, the CD segment, so on and so forth. So it says, with reference to the journey, explain what is happening between line segment A and B. So if I'm looking at that line segment right here, you can see that the time is going forward and the amount of fuel is going down. So they're probably driving, right? If I had to guess, I would say they start their journey. They start with 50 liters in the tank and drive for, well, they go from 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock. So they drive for 3 hours. I think that makes sense. What's happening between B and C? So now we're looking at this section right here. So it looks like it is about half an hour long, and they're not losing any fuel. So I would say if they're not using any fuel, they must have stopped for lunch, maybe. Maybe they just stopped for a rest. And then the last one we're going to look at is line segment C and D. So we're looking at that one right there. And you can see that no time has passed between C and D. They're right along the same time, but the fuel has gone up. So they filled up their tank. They filled up the gas tank. Perfect. I'm going to zoom out just so we can see. That's a zoom in. Whoops. Just so we can see the graph and still answer the questions here. The next question says, what is the rate of fuel consumption in liters per hour between D and E? So what we want is, we want our answer in, I'm just going to do this over here. We want it in liters per 1 hour. So how many liters do we use in 1 hour? That's what liters per hour means. So we can, the easiest way to do this is to say, well, we started with 60 liters of fuel and we ended with, it looks like 25. So how many liters of fuel did we use? So 60 minus 25 should give us 35. So we used 35 liters in, well, 1, 2, 3.5 hours. So if we used 35 liters over 3.5 hours, and you actually do that division in your calculator, 35 divided by 3.5, what happens is you get 10, and that represents 10 liters per hour. So the rate of fuel consumption was 10 liters per hour. Which line segment represents the car being refueled for a second time? So where do they fill up for gas a second time? Well, I would have to guess this one because no time has passed and our liters are, the amount of liters we have in the car is going up. So they're probably filling up again. Calculate the total time, or wait, we have to answer that, GH. Calculate the total time the car was driven. So any line segment that is losing fuel, the amount of fuel means that they're driving. So you can see in A to B, they are traveling for, boom, to there. That is 3 hours. 3 hours. And then they start driving. Well, we already calculated this one. We said this one here was 3.5 hours. And last but not least, we have another segment of driving right here, which is 1 hour. So 3 plus 3.5 plus 1 is they drove for 7.5 hours. If fuel costs 85 cents per liter, calculate the cost of fuel used for the first day of the journey. So 85 cents and per liter, and then we have to multiply it by how many liters that we used. So now it's up to us to figure out how many liters were used. So we'll scroll back up here, and we can see, well, how many liters did we use between A and B? We went from 50 to 20, so that's probably 30 liters. And then we went, in this segment here, we went from D to E. We went from 60 to 25, so that was 35 liters. And then in this one here, we went from 60 to, looks like 50, so 10 liters. So 30, 35, and 10. 30 plus 35 plus 10 gives us 75 liters. So we use 75 liters at 85 cents a liter, and that is going to give us, I don't have my calculator. Oh, we used 85 liters? Did I get something wrong here? Oh man, I totally missed. You're probably all laughing at me right now. I totally missed another driving section. We were driving right here as well. That's not only going to change the amount of liters we use, it's going to change the time. So that adds 1 extra hour here. So that means that the total time driven is going to be 8.5 hours. And we used another 10 liters of gas there. So if we add 10, that is going to be 85. I'll just erase it. I thought that would work better. So we actually used 85 liters at 85 cents a liter, and that, if we multiply together, will be $72.25. So just from that graph, we were able to gather a lot of information and solve a lot of problems. A lot of this is going to be just looking at a graph and trying to describe what's happening. So if we look at graph A, we have speed versus time. So what is happening, there can be all sorts of things happening here. We could start by saying, okay, well, we're driving at a constant speed. So in A, driving constant speed. And then B will be the next one. It looks like our speed is decreasing, so maybe we slow down for school zone. And C, it looks like we going through school zone because we're going slower. And then in D, we speed up again, right here. And then E, constant speed. And then finally F, slow down as we get home. Slow to a stop. So in that case, I broke it down into line segments. There are other ways to do this. Like in example B, we can see that we're going from really slow and fast and then slowing down again to almost nothing, and then fast, and then slowing to 0, and then going fast and then slowing down. This could definitely be a pendulum, right? So if you have your pendulum hanging, as you pull it back, it's going to go back and forth and back and forth. So as it moves up, it's going to stop for a second at the top, and then it's going to speed up and go fast. It's going to be moving really fast at the bottom, then it's going to climb back up to the other side and come to a stop, and then it's going to go back the other way, again being maximum speed at the bottom, and then slowing down. So this could be a pendulum swinging back and forth. So it's just about being a little bit creative and trying to figure out what could be going on. So now we are going to use, we're going to sketch a graph and with no scale, just to try to represent what's going on. So the first one is the oven temperature when baking a pie. So, your temperature probably doesn't start right at 0. It's probably room temperature in your oven. So we'll start right here. And then it warms up to baking temperature. And then it stays baking temperature for the hour or whatever that you bake the pie. Then you turn it off because the pie's done, and the temperature will decrease back to where it started. So something like that, probably with straighter lines, but I got wiggly writing. Ben taking part in a 100-meter sprint. Well, he's going to start at 0. His speed's going to increase, but probably not constantly. So he'll probably go up, something like that. Woo! Now he's traveling at constant speed. Then he crosses the finish line, and he slows down. Something like that would work. All right, so we just covered a lot. We looked at using function notation to solve problems. We looked at getting information from graphs. Both of those are pretty awesome units to put together, or lessons to put together, and I'm happy that we're able to do 2 videos at once. Great job. Don't forget to like and subscribe.